Number 15 then from the 2017 Mathematics of Mechanics, 6 marks this time. Looks like you have to derive a differential equation and then solve it. What does it say? A car of mass m travelling along a straight horizontal road experiences resistances of total magnitude this means all the various resistances added up together. It's travelling with a constant, producing a constant power of p watts. You have to show that this is the case where x is the distance measured from some origin. Well, so what are the sum of the forces on this car that's travelling along? It's producing a constant power, deriving it that way. It's meeting a resistance, that's this force of total force of friction that way. So that power will produce a force in that direction. So you could work out the net force then. The net force is going to be, now what's the connection between power and force? Power is the rate of doing work. Work is force times distance. So it'll be the force times the rate of change of distance. So it's Fv. So that could be replaced. This F must equal P over V. So you've got P divided by V going that way, I should have mentioned that, minus this force going that way. That's an unbalanced force, hopefully, because it's moving, so that should produce an acceleration. Now, there's 1 mark just for doing that part of it, rather than doing the whole sum of the forces thing. Now, there's no mention of A in this, notice, but that's because there's a connection between A. You know that A is dV by dt, but it can also be written as A equals V dV by dx. So that's long to do, I'm just going to put that into this. Write it the other way around, so I'll put this at the front. So instead of MA, I'm going to write MV dV by dx. And instead of this, because I can see this is meant to be a single fraction, I'll just add those 2 parts together. Common denominator 6v. So that'll need a 6 multiplying it. Oops. And that'll need a v multiplying it. And you're almost there. Take the mv down to the denominator, so it's 6p minus mkv cubed, that's right, over, and m down underneath, 6m, and another v, making it v squared, and there you go. And part B. If the car starts from rest, where there's some initial conditions in, when x is 0, v is 0, find an expression in terms of all these bits and pieces, k, p, m and v, for the displacement of the car while it's accelerating. So you wanted to read x equals. In other words, you have to solve that differential equation then. Well, there's only v's involved here, so you can separate the variables quite easily. They can all go across and join dv, and dx can come over on its own, but I'll write it the other way around. So I'll bring the dx over, and I'll have dx equals. I'll bring this over to join the dv, but write it on the other side. So I've got 6mv squared on top, but 6p minus mkv cubed underneath, and that joins the dv. Separate the variables. How can you get back to x? Build it up. Integrate it. There's the first mark. Now you can either integrate it the way it is and end up with a plus c, then use the initial conditions, or you could put limits in. I think I'll just integrate it with a constant. So integrate, that side's easy. That just goes to x. Now this side, it might look a bit clumsy, especially with that denominator, but look at the top. That's got v cubed, that's got v squared. The top is related to the derivative of the denominator. And when I say related, I mean it's a multiple of it. And if the numerator is a multiple of the derivative of the denominator, you've just got a logarithm. You can do it by inspection then. What multiple have you got? Well, the top is 6mv squared. The derivative of the denominator, that disappears, is negative 3mkv squared. So you can see it's a multiple of it. Those parts cancel out. There's a multiple. Negative 2 over k. So that must be negative 2 upon k ln of the denominator. all inside the absolute value, plus c. Doing that gets the second mark. If you recognise that you've got a logarithm because the numerator is a multiple of the derivative of the denominator. If you don't, then you'd have to carry out a substitution. Let u equal this big clumsy bundle, 6p minus mkv cubed. So du would be, that disappears because it's differentiating with respect to v, negative 3 mkv squared dv. Right, so the denominator is replaced with u. The numerator, I'll just put that in just now because hopefully it'll cancel out. If there's any bits left over, I'd have to go back to my substitution, but hopefully it all clears up nicely. So dv would be du divided by negative 3 mkv squared. Look, see, there's that same thing again. There's the numerator over the derivative of the denominator to give the multiple. That all cancels out. If you're negative, 2 on top and k underneath. Negative 2 upon k times the integral of du over u. So that means it goes to negative 2k times ln of u plus c. So negative 2 upon k ln of the whole thing, 6p minus mkv cubed plus c. There, that was the long way round to get to the same result. Now I need to find c. I think I'll just do that here. Initial conditions. When x is 0, v is 0. It starts from rest. So when x is 0, ln of, v is 0, so it's just 6p. In that case I don't really need that, because 6p is definitely positive, plus c. Well, there you go. c is equal to 2 upon k ln 6p. There's a mark for that. Now just pop it back in and here's your answer. Now that's negative and that's positive, so I'm just going to put that one first. 2 upon k ln of 6p minus 2 upon k ln of the bundle. Now actually at that point they give you the last mark. But it's really crying to be tidied up because look, there's a common factor here of 2 upon k. And with the 2 upon k out, you've got a log minus a log. So that can go down to a single logarithm of the quotient. A single logarithm of 6p over 6p minus mkv cubed. I'll have to put the absolute value back in again. That's much neater. I'd put the answer there, but they've got it there.